The source of stellar energy. Stellar energy comes from the fusing from hydrogen to helium. As you see, hydrogen starts to fuse into higher elements and to other isotopes. Then these hydrogen starts to fuse with the other isotope, then it starts to form helium, and here it goes, this process, until it forms a stable hydrogen, helium. And there are lots of emissions that come with this, like gamma rays and neutrinos. And the more the massive the star and the pressure and the temperature, the more this star starts to form higher elements. There are two ways for energy transport in the star, in the forming star. Or, as we know, there are three types of energy transport, like connectivity, when you two bodies with different temperatures touch each other, so energy starts to transport till they reach equilibrium. There is another way, like radiation, which is when a body is very hot and excited, so it starts to emit photons and heat, and energy it starts to transport due to this radiation. And the last way is convection, and convection is when two mediums, like two pieces of glass in a double skin glass, and between them there is air, so when the temperature moves from one side to the other due to the movement of air or the gas, this is called convection. It's the energy transport caused due to the variation of densities of that gas. Like in this video, in this image, the hot gas starts to evolve and go upwards, and the cool ones, which is darker, starts to move down. And this happens in the sun and any star. And in the sun, this happens in the photosphere, and it's called the granulation, because you will see the sunlight, it has granules, because some parts, the cooler parts, will look like they are dark, but they are not. They're not dark. This is because of your eye. So this is the convection in the sun. There is a radiation from the core. The core radiates energy, then this energy starts to heat the gases, so the gases start to rise up and the cool starts to move down, and that's how the flow of energy happens. And of course the core is giving energy that comes out of fusion reactions. Okay, there is something very important that you have to realize: the hydrostatic equilibrium. The hydrostatic equilibrium is the equilibrium between the hydrogen and helium production to the gravity. So the fusion energy that happens in the core of that star starts to give temperature, which means expansion, and the gravity or positive energy, but the gravity is negative energy, it starts to act on attracting and the star. So there must be equilibrium between both. So in very high massive stars with very high activity, they would die soon because they would explode or eject lots of its contents and lose its fuel because of the very high activity. However, it's not the same in non-active stars, because they live longer, because they can the gravity holds it and it does not eject lots of bodies. So if the gravity is higher, this star will collapse on itself. It will collapse. And if it's less, it will explode. So there is a ratio between gravity and the fusion temperature. And that's why there is something called the main sequence stars, that there is a relation between the temperature and luminosity and gravity and mass and age, because of this equilibrium. So imagine a star's interior composed of individual shells. Within each shell, two forces have to be in equilibrium with each other: gravity, i.e. the weight from all layers above, and outward pressure from the interior, that is called due to the high temperature and the fusion reactions. So these are the shells and the pressures and the gravity acting in equilibrium. Outward pressure force must exactly balance the weight of all layers above everywhere in the star. This condition uniquely determines the interior structure of the star. This is why we find stable stars on such a narrow strict main sequence in the Hertzsprung-Russell diagram. That's why stars are always here. There is a ratio between temperature and luminosity and mass in this direction, and radius, because this equilibrium must stay always, or the star will not be there. You will come to an end. And there is also a ratio between mass and size. There is also a ratio between them. So these are nebulae, different nebulas having activity, and protostars and stars forming, and they are going to their main sequence stage. Okay, this was our lecture today, and thank you so much.